In this video, we're going to continue with the exploratory data analysis, and now we are going to have a closer look at the numerical variables. If we have a careful look at the documentation in Kaggle, we will find that we have three variables that are temporal. These are the variables that represent the year in which the house was built, or the year in which the house was remodeled, or the year in which the garage was built, and then the year in which the house was sold. I can capture these variables in a list by using a list comprehension where I loop variable per variable in the numerical variables if the string year is in the variable or the string year is in the variable. So if I print this, I can see that I can capture correctly the temporal variables. I can go ahead and explore the unique values of each one of these year variables, and I can see that they are indeed years, which is what I expected if I read the description of the data, and if I didn't read the description, as soon as I explore the values, I can kind of understand that they are in fact years. We can then explore the evolution of the sale price of the houses in the years in which the house was sold. So here I group by the year in which the house was sold, which we can see that is just over 5 years. We don't have more data than this. And then I calculate the median price in each one of these years, and then I make a plot. And we can see that the median price per house sale drops towards the latest years. And this is kind of funny because in most cases the houses only get more expensive. So we can explore this further to see what might be going on. In this plot, we're going to group by the year in which the house was built, and then we estimate the price, and we can see that in fact the median price of the house increased with the year in which the house was built. This means that, of course, newer houses are more expensive. So we can hypothesize that the house price in the years in which the sale occurred drops because maybe we are selling older houses in that year. So in order to analyze that, we are going to create this function that takes in the data frame and the variable that I want to analyze. I make a copy, so I make sure not to overwrite the data frame. And now I determine the time between the year in which the house was actually sold and the year in which the house was built or remodeled, or the year in which the garage was built. Then I group by the year in which the house was sold, and then I determine this elapsed time between the sold and the building of the house, and then I plot it. I do this for each year variable, and what I see is that more clearly, perhaps for the years in which the house was remodeled, as the time passes, we are selling houses that are older. So this 16 means that there are 16 years between the time where the house was sold, that it was 2010, and the time in which the house was remodeled. So indeed, it looks like we are selling older houses, and that's why we see the drop in the price. All of this, of course, is my speculation. I know nothing about the dataset, but this is what the data is telling us. I can go ahead and plot this elapsed time versus the sale price in a scatter plot, which is what I do here, for each one of the year variables. And we can see indeed that the sale price decreases as the difference between the time in which the house was sold and the time in which the house was built increases. So sale price decreases with the age of the house, in other words. And this is true for the years in which the house was remodeled, and also for the years in which the garage was built. In the next video, we're going to explore discrete variables.